So in this video, I'm going to show you how to model the motion of a particle in a straight line with variable acceleration. So if displacement s is expressed as a function of time t, then velocity is the rate at which the displacement changes over time. So velocity is the change in displacement divided by the change in time. And acceleration is the rate at which velocity changes over time. So this is the change in velocity divided by the change in time, or the second derivative of the displacement. So we can use all of this to work out example 1. We're told that the displacement in s meters of a particle after t seconds is given by this function, this displacement function. And we've been asked to work out an expression for the velocity of a particle. So we know that velocity is the change in displacement divided by the change in time. So this is the first derivative ds by dt of this function. So when we differentiate this, the 100 is a constant, so this will go, and then the 5 times the 2 will make 10, and we'll take away 1 from this power. So this will become 10t, and this is in meters per second. Okay? And then for part B, work out the velocity of a particle at 3 seconds. So we'll substitute t equals 3 into v. So the velocity will be 10 lots of 3. All we've done is substituted 3 into here. And this will be 30 meters per second. And then for part C, find an expression for the acceleration. Well, acceleration is the change in velocity divided by the change in time. So we just need to differentiate v, which is 10t. We differentiate this, we get 10. So the acceleration is 10 meters per second squared. Okay? Let's move on to example 2. So in example 2, we're told that the displacement s meters of a particle after t seconds is given by this function, and we've been asked to work out an expression for the velocity of a particle. And then for part B, find an expression for the acceleration of a particle, and for part C, find an acceleration for a particle at 5 seconds. So if you want to try question 2 yourself, you can pause the video, and when you come back, we'll go through the work solution. Okay, so for question A, the velocity is the change in displacement divided by the change in time. So we need to differentiate this function. The 20 is the constant, so this will go. 48 times the 2 will make 96, and we'll take away 1 from this power. So this becomes 96t. And then 12 times 3 is 36, again taking away 1 from this power. So minus 36t squared. So this is the velocity. The acceleration is the change in velocity divided by the change in time. So we'll differentiate this function now. The t will go, so we're left with 96. And then 2 times 36 is 72, and we'll take away 1 from this power. So minus 72t. And then for part C, work out the acceleration at 5 seconds. So we'll substitute t equals 5 into the acceleration. So we get the acceleration will be 96 minus 72 lots of 5. And this works out as minus 264 meters per second squared. Okay? So for question 3, we're told that the displacement of a particle from a fixed point after t seconds is given as this, where t ranges between 1 and 5 inclusive. And for part A, we've been asked to work out the expression for the velocity, for part B, the acceleration, and then for part C, find the displacement, velocity, and acceleration at 2 seconds. So do you want to try this question yourself? You can pause the video, and when you come back, we'll go through the work solution. Okay, so for question A, we can work out the velocity as a change in displacement divided by the change in time. Before we can differentiate this, we need to write this in a more convenient form. So we'll say that S is equal to 5t, and this 8 divided by t, we can write as 8t to the minus 1. When we differentiate this now, this t will go, so we have 5, and then we'll have negative 1 times 8, which is negative 8. We'll take away 1 from the power, so 8t to the minus 2. And I can write this a little bit more convenient, 5 minus 8 over t squared. Okay, so for part B, find an expression for the acceleration. Well, again, this is dv by dt. So we'll differentiate this function. The 5 is a constant, so it will go. And then we'll have the negative 2 times negative 8, which is 16. We'll take away 1 from the power, so 16t to the minus 3, or 16 over t cubed. And then for part C, when t equals 2, we'll substitute 2 into each of these equations to get the displacement, velocity, and acceleration. So S will be 5 lots of 2 plus 8 over 2, 10 plus 4, 14 meters. And the velocity will have the t in here, so 5 minus 8 divided by 4. 5 minus 2 gives us 3 meters per second. And for the acceleration, we'll substitute 2 in here. 2 cubed is 8. 16 divided by 8 is 2. So 2 meters per second squared. Okay? Let's move on to our final question, question 4. So in question 4, we're told that the displacement s meters of a moving particle q at time t is given by this function, where t is greater than or equal to 0, and we've been asked to find the time at which a particle stops. So do you want to try this question yourself? And when you come back, we'll go through the worked solution. Okay, so welcome back if you had a go. So the first thing we need to understand is that when a particle stops, the velocity is 0. So we need to work out the velocity. And we know this is ds by dt. So we'll differentiate this. 3 times 3 is 9. So it's 9t squared. And then this negative 4t becomes minus 4. And when the particle has stopped, this equals 0. So 0 equals 9t squared minus 4. We can solve this equation by factorizing, because we have a difference of 2 squares. So 0 will equal 3t plus 2 and 3t minus 2. This will have a solution at t equals minus 2/3. And this will have a solution at t equals positive 2/3. We're told in the question that t has to be greater than or equal to 0. So this cannot be a valid solution. So our solution is t equals 2/3 of a second. Okay, thank you for watching, and I hope you found that useful. You can download the full lesson and worksheet from our website, mrmathematics.com.